Good day, guys. Today we are taking example under Routh Stability Criterion. The question says find the Routh array of the function Q of s is equal to s raised to power 6, s raised to power 5, 5s raised to power 4, 3s raised to power 3, 2s raised to power 2, plus 4s minus 8. Okay. There's nothing wrong with this one now. This one is easy as ABCD. We'll draw our array line again, or table, whatever you choose to call it. Then we have the highest power we have here is what? S6. So we start from there. S6, S5, S4, S3, S2, S1, S0. Then the coefficient of S6, 1. What of S5? 1. What of S4? 5. S3, 3. S2, 2. S1, minus 4. And constant, minus 8. You can put 0 here. Okay, and our S0 also have what? Minus 8, representing the what? Constant. Okay, so at least for us to have minus 8, it means that this system is unstable already. Because from here we are already having plus plus, and we haven't even gotten to the final answer, but we're already seeing a minus. That means there's a change in sign at a particular point, and we already see one change. So at least just from this minus 8 being here, we already know that the system is unstable. But another thing that we don't know, but Routh Stability Criterion can tell us, is how many of the poles. I think we're going to be having about 6 value of s's if we solve this. But we don't know how many of them are on the left hand side, how many of them are on the right hand side. But we can get that using what? Routh Stability Criterion. Okay, now let's start solving. So we need to get B1, B2, B3. Definitely, whatever will be here will be 0. Since this diagonal is also what? Empty. We also need to get what? C1, C2, C3, and so on. Okay, C3 will definitely be what? 0. Since this diagonal are what? 0. Okay, now we're also going to be having both D1 and the rest. We have D1, D2, D3 will be 0. Right? Then E1, E2 will be 0, 0, 0. Okay, now let us solve for B1. B1, like we said, we will take this first one always, and the next one is diagonal to it. So we'll be having 1 times 5. Remember the minor minus the major, minus 1 times 3 over what? 1. 1 times 5 is 5. 1 times 3 is 3. 5 minus 3, we are having 2. We are having what? 2. So what it means is that B1 is what? 2. B2 on the other hand, will be this one and this one. So we'll be having 1 times 2 minus 1 times minus 4. This is 2. This is plus 4. So we're having this over what? 1. The 1 is because of this guy. So we'll be having what? 6 for this one. Moving over to B3. B3 can still go. B3 will then be 1 times minus 8 minus, what else? 0 times what? 1 over what? 1. This is definitely going to give us 0. So we're left with what? Minus 8. So we'll be replacing this with what? 2, 6, and what? Minus 8. You got that? Now, going over to C1, we take this and this. That will be 2 times 3 minus 6 times 1 over 2. This will give us, this is 6 minus 6, that is 0 over 2, which is what? 0. So our C1 is what? 0. C2 on the other hand is now going to be C2. This is it. So it's not going to be for this one and this one. So we're going to be having 2 times minus 4 minus 1 times minus 8 over what? 2. This will give us minus 8. This will also give us what? Minus 8. Minus times plus and minus here is going to give us plus. We're having minus 8 plus 8, which is going to give us 0. So we're also having what? 0 over what? 2. This will give us what? 0. So C2 is now also what? 0. It's now also what? 0. So we'll come here and do what? Replace it. Now the issue now is if there is now 0, how can we now get what? D1 and D2. Is it possible? Let us try for D1. If we were to try for D1, we have 0 times 6 in brackets minus 0 times what? 2 in brackets. All of this divided by what? 0. Definitely, this will be introducing what? Infinity. So this is our major focus here is what? Sign. And now we're not seeing infinity in what we are solving. So this is one of the special cases in Routh Stability Criterion. There are some cases you will solve and you start seeing that whole rule will just become what? 0. And you will just kind of be like, but if you solve this thing, to be giving you some, it will not be giving you a tangible number. So how are we going to do in this case? So the solution to this is for you to return back to the row before this one that's having all these zeros. Return back to this row. We return back to the S4 row, and we're going to be rewriting this whole stuff here together with their s's. So we're going to be having 2s4 plus the plus is because of 6 is what? Positive, plus 6s2. It's not going to be s3 but what? S2 minus 8. This is the expression we're going to be we got from this what? S4. So in case if this S4 is now let me say S5, if this happened in S4, we have to make use of if these zeros occurred in S4, we make use of what? S5. Here will become S5, here will become S3, here will become just like that. Like give a interval of 2 from the two of them. Let it be that the difference between this and the next one will be what? 2. The same thing, this and the next one will be what? 2. Okay, now with that being said, now we're going to differentiate this guy. We're trying to differentiate him because since we have solved and we're getting 0 here, we're trying to find a way we can avoid this 0. So the only way we can do this is by what? Differentiating this guy. When we do that, we have 8s3 plus 12s. Differentiating the constant, you have what? 0. Remember, your differentiation is you subtract 1 from your power, and that's your power. You multiply it to the whole number in front. So if you multiply 4 to 2, you have 8. Subtract 1 from your 4, you have 3. And so on. The same thing goes for this one. Multiply 2 to your 6, you have 12. Subtract 1 from your 2, you have what? 1. So you have s raised to power what? 1, because you subtracted the 1 from this one. So this 8 and 12 is now what you're going to be using instead of 0, 0 in this S3 s raised to power 3 row. So this is when you're going to be cleaning this. We'll be replacing that with what? 8 and what? 12. So this is only this thing I just did now only applies. We call them special cases in some Routh Stability Criterion. This only always occurs whenever you are having zeros in an entire row. The whole row, no single number. It's the only word, and it's not the last number. Everything you're seeing there is just what? 0, 0, 0. Okay. Now, with that aside, let us we'll continue solving. So we only did that one especially for this one. The same procedure will still continue for the rest. Now for our D1, we're not going to get our D1 now. Our D1 will then be these two columns that is directly above it. So it will then be 8 times 6 minus 2 times what? 12 over what? 8. Right? Okay. So we are going to be having 3 is our answer. Now solving for D2. D2 will then be this two column, this and this. Now it will then be 8 times minus 8 minus 2 times 0 over what? 8, right? This one definitely give us 0. So we'll be having our answer to be what? Minus 8. So we replace our D2 and D1 with what? 3 and what? Minus 8. Okay. Now, we then go over to E, which is a last unknown that we don't know. For our E, we'll be considering just these two column, the two of them. Now we'll be having for E1, for E1 we'll be having 3 times 12 minus 8 times what? 8, right? Over what? 3. Okay. Now, when you solve that, you'll be having it in fraction, which is what? 100 over 3. So that's what is going to be our answer here. 100 over 3. So whether I write it in decimal or write it in fraction, the only thing we're interested is what the sign what change. So now from what we can see now, you can see that the sign didn't change to this last one. So to this point, we're having what? Plus. 19 then change to what? Minus. So we then have only what? One change. Now you can go for that too to reduce. Like for this row, you can choose to reduce it. Just know that you can reduce each row in a Routh stability array. Just know that, but it doesn't have much impact since we're really interested in the signs of the first column. Okay, now so we can then write down the statements and said and then say that the transfer function or the closed loop function is what? Unstable, and there is one root or pole on the right hand side. So that's for this case. Now let's take one more example before we go. The question says find the Routh array of the function q of s is equal to s raised power 4 plus s raised power 3 plus s raised power 2 and 2s raised power 2 plus 2s plus 5. Okay. Now let's start solving. First, we draw our line. Yeah, since we're having the highest power here to be s4, start from s4, s3, s2, s1, s0. We know s0 definitely be what? The constant. Then s4 we have what? 1. s3 we have what? 1. s2 we have what? 2. s we have 2. This we have what? 5. Then we can put 0 here to fill up the gap. Alright? Okay. Now it's now left for us to get B1, B2. Then here will definitely be what? 0, because this 2 is what? 0. Now and what? C1 and what? Here will definitely be what? 0, because this place is what? 0. And here 0 too. Okay. So for our B1, we will have, remember we're taking these two column, right? So we have 1 times 2 minus 1 times 2. This times this, right? Over 1. Now this will definitely give us what? 0 over 1, which is what? 0. Then coming over to B2 will give us this and this. So we have 1 times 5 minus 0 times 1 over 1. Now this will give us what? 5 as an answer, right? Okay, now we are having 0 here. We are having what? 0 there. Now that is an issue. That's an issue because our 0 doesn't belong to either negative or what? Positive. It is neutral. So we are interested in sign mostly, especially of our first column in this Routh Stability Criterion. So this guy is neutral. This our 0 that is neutral for our B1 is a problem. Okay, now this is the second special case under Routh Stability Criterion. When the first value is what? 0, but there is a number on that row. In the first case that we treated, the entire row was 0, but in this case now we're having at least one number. So in this situation, that's the way we solve this. Okay, now we don't, this 0 will create a problem for us. So we won't be writing 0. How we solve this is we won't write 0. Instead we replace 0 with this, right? We'll replace our 0 with that. How we do that here? Okay, now we cannot start solving. Remember, this only works when at least one of the values on that row is a number. In the first case, the entire thing was what? 0. But in this case, we're having 0 and 5. So we treat it in a different way. So we replace our what? 0. We don't write down 0. We replace it with what? This eta sign. Right? Now, then we'll continue solving like that. Remember, the eta the eta is representing what? 0. So though we don't write 0 there, but you should know that it is what? Representing what? 0. Now for our C1, our C1 will be this and this, right? So we have eta times 2 minus 5 times 1, right? Over eta. Okay, this is equivalent to 2 eta minus 5 over what? Eta, right? You can also write this, if this and this are to cancel out, you can write this to be 2 minus 5 over what? Eta, right? Okay, now 5 over eta, taking our eta to be 0, will give us what? Infinity. Anything divided by 0 is what? Infinity. So we are having more like 2 minus what? Infinity. And any number plus or minus infinity will still give you plus or minus what? Infinity. So let's say the number is a, and you're plussing and subtracting it from what? Infinity. So definitely give you what? So in this case, we have our answer to the what? Minus infinity. But you see, we won't be writing minus infinity in the Routh table. Instead, this is what we'll be writing down, this expression. So this is one disadvantage of this particular method, is that you have to know its outcome, or you have to be familiar with this particular rule. So and be very conversant with your with solving with your infinity sign, because if you don't know how to do so, you won't know that there's going to be a sign change here. So though we are writing it down, there's a change of, there's going to be a change of sign around this place. From what we've solved, we are seeing what? Minus infinity. So whatever our value is going to give us, is going to be giving us a negative sign. Our main focus is not the value, but the change of what? Sign. Okay, now if we are asked how many times, or if we are asked if the system is stable, it is not stable because of what? There's a change of sign in this part. So from here we have plus, from here we had plus, then change to what? Minus, and then back to what? Plus. So this is going to be 1 2 2 what? change, right? Now, this is one way of solving it. This is one way of solving. Another way we could solve it. Another way we could solve this will be us exchanging the values of this equation. So you exchange the first coefficient to the last coefficient. Exchange the second to the last coefficient to the second one. Since we're having one particular one, we'll leave this one. So we'll be having that 5s raised to the power 4 plus 2s raised to the power 3. Exchanging this coefficient with this one. Since we're having only one in the center, we'll leave it like that. Then this one, whatever was here, came over here. We'll be having what? Plus s, and this one over here, we're having what? Plus 1, right? Now this is what we're going to be using to solve. This is another way of solving it. Now we have what? S4, S3, S2, S1, S0. Now our S0 definitely carry the what? The constants. For our S4, we are going to be having what? 5, S3, 2, the next one, 2, the next one, 1, and finally what? 1. Okay, now we fill up here with what? 0. Okay, now we'll be having our B1, B2, and C1. Okay, I hope you know why we don't have C2. It is because of the values that are diagonally above it is what? 0. So for that to be 0, it means our place is definitely going to be what? 0. You can try and solve it, you will still see it will give you that value. Okay, now solving for our B1, we don't have what? This will be this column and this column. So we have 2 times 2 minus 5 times 1 over what? 2. This is going to definitely give us 4 over, no, not 4. This is 4 minus 5, that is minus 1 over what? 2. So our B1 is going to be giving us what? Minus half. Remember, our main focus is what? The sign change. Okay, so for our B2, we have our value to be 2 times 1 minus 0 times 5 over what? 2. 2 times 1 is what? 2 minus 0. Okay, this is going to be giving us what? 1. So we replace this with what? 1, right? Then finally, solving for what? For C1. Solving for C1, we have minus half times 1 minus 1 times what? 2 over minus 1 over what? 2. Right? Okay. Now let's solve this with a calculator. Let's see what our answer will be. I got my answer to be what? 5. Okay. Now our C1 will then be what? 5. Okay. Now we then ask ourselves if the system is stable. The system is not stable. 1. And how many change in sign? From here we had plus, then later change to what? Minus, and then back to what? Plus. So we are having what? 2 changes. Similarly, when we use this method, we got the same answer. So it's either you use this or you use this, whatever you prefer. Okay. Now, so we can write down a statement that the system is what? Unstable. I hope you know the reason why, because there's a change in sign. And the number of poles on the right hand side is what? 2. Please always endeavor to write down these statements. This is to show that you know what you're doing. Okay, so that's all for this video. Subscribe, like, share, and comment, and keep being the best version of yourself. See you guys in the next video. Goodbye.